Hello, everyone, and welcome to the Standstill and Hot Mix podcast. As our introductory series, we're going to work today with silo systems and drag slat conveyors. My name is Steve Elam, and I'm joined here with Tony Fritsch.
Howdy.
And we're going to try and address a topic of drag slats, bin top or transfer conveyors, delve into silos and different aspects. And once again, as you watch, we're continuing to ask you to put comments for topics that you would like to discuss further, whether that's any typical type of conveyor you have, silo systems, or any question for that matter, because over time, our goal is to cover all the topics of the different types of equipment on the asphalt plant. And the ultimate goal is to provide input and feedback from yourselves and discuss the topics of maintenance, the operation of the equipment, and create a beneficial site. So with that, Tony, we'll get started on drag slat conveyors. So Tony, if you could, a little bit about what you've done on some of the drag slats from an original equipment design into so much of the aftermarket for fulfillment.
Yeah, so we've rebuilt just hundreds, if not thousands, it's got to be thousands of drag slide conveyors
Many
over
thousands.
these years. Yeah. And we've done everything from replacing just OEM components to trying to make them be able to handle more production. Some of that might be changing the chain and slats inside of these, because we've changed conveyors from a single chain system to a double chain system, complete drive rebuilds. Because as you said, it's just a big square steel tunnel, and all the components inside of it is what does the work. And the floors wear out, the sideliners wear out, the slats, everything about it wears out. But when you change out the internals, you can really make a difference in production. We've changed slats to where we put like risers on the back of them to prevent rollback. Just a myriad of different things to make them handle more production.
Yeah, let's talk a little bit about the applications. I referenced these into stationary, portable, batch, drum plants. On the portability side, it gets a little more interesting in that these systems typically need to be erected. Therefore, many times you hear the SEB or self-erect bin or silo systems. They can be anything from a surge storage capacity where it's a reverse way silo and shorter drag slat conveyors feeding them, all the way up into larger systems that are set up in more semi-portable applications, many of which may over time turn into stationary applications. Then all the way up into high production facilities, as many as 10 silos in operations, and those numbers are increasing. 300 tons per silo storage. In one of our plants I know we built many years ago, just under 1,000 tons per hour. When we get to that type of capacity, drag slats at some point in the 600 to 700 ton per hour range, it becomes more viable to go to an asphalt bucket elevator. Asphalt bucket elevators can essentially do thousands of tons per hour.
Yeah, that hydraulic floor clean out made all the difference, so
It really does.
It's basically push button clean out. I remember going up on an asphalt bucket elevator job in Chicago. You're talking about higher population where you have to have a smaller footprint. Me and one of my colleagues went up there. We were trying to check and see if this thing was actually bent because they were having troubles with bucket wear on the sides. And blowing snow, Chicago, windy, top of a bucket elevator, not comfortable.
Yeah, thus some unpopularity. Not that a drag slat is low profile by any means. Going back to drag slats, what are we doing with both these devices? We're trying to take completed hot mix, in other words, finished product mix, and we're trying to get it from grade level or some reasonable elevation up and into a level where it can be distributed into silo storage systems. So the drag slat is a preferred design. It allows for this. It handles high level capacities and tonnages that are the asphalt plants operating ranges of different sizes, different manufacturers. On continuous plants where we have startup and shutdowns, we have to have some waste involved, as minimal as possible. But the fact is, it has to be capable on the fly to provide a exit strategy, if you will, or a portal to waste material. If not, there has to be some type of divert up top, or the limitation of having to use one silo that always has to be empty before we can start up, which is a highly undesirable situation. So therefore, if we don't have a divert of some form at the base of the drag slat, common practice is it would have some form of a chop gate or false bottom trap door in the drag slat, approximately a third of the way up, or varying depending upon needs, or we'll waste that. You do a lot of retrofits in that application, I guess, because some places did batch plants, or for whatever reason, a lot of these drags didn't have that.
Yeah.
Tell us about how that works.
Well, we have customers call from time to time wanting to put a new reject gate in, and we usually have them, locate that at least 20 feet off the ground, something along those lines, so you can get a truck underneath of it. Sometimes a lot further off the ground, but there are so many different size bucket elevators, and we're familiar with a lot of different sizes from a lot of different manufacturers. But we usually start off with like a fill in the blank type of drawing. So I've got sketches of what the profile of the drag slat would look like if you cut it in half, so to speak. And having those measurements, we can design and fabricate a new reject gate system for existing silos, and we've done a lot of that. The heat that goes up the bottom of those things a lot of times is hot oil, and those hot oil tubes have to be interfered with on the way up through there. I've had customers that just return the hot oil right before the reject gate instead of continuing it all the way up the slat, or we use jumper hoses and the like to go around that gate.
Yeah.
Well, we've done a lot of that.
Yeah. Some of the things, I like to make it as simple as possible in a drag slat conveyor. While we don't want the slack in the conveyor in the chain to be slapping the doors off of a bucket or the drag slat, if in doubt, more loose is better. In other words, more slack is better. It's one of the few places around an asphalt plant that we actually get the great benefit of the ability to monitor something like that is in the most desirable place. The return side of the chain down towards grade level, those first few doors are the best place because that's the end of that catenary sag coming back. And you're going to see your greatest measure right there where it's convenient, and you can tell what's going on.
Right on top, right on the ground, easy to get to.
Absolutely. So if in doubt, make it looser. We see so much wear that occurs strictly from the good intention of trying to tighten the chain. Also, one thing that occurs out there, kind of a caveat to that or a sidebar to that tightening, oftentimes on a head take-up assembly on a drag slat conveyor, there's usually a very large, commonly 45 or 40 tooth driven sprocket up there that is virtually the size, if not larger, of the height of the conveyor. They're very large diameter or pitch diameter, and it doesn't make it totally convenient to tighten on one side with the chain guard in place. So oftentimes, kind of like trunnions, people will adjust one to get an outcome that all need to be adjusted. So on a head take up or a tail take up, we need to adjust both sides equally and knowingly that it's square to begin with. In addition, depending upon how the setup is up there, what else do we need to look at up on top, Tony? Because one of the things that's arguably the worst thing about a drag slat conveyor is that everything is working great until it doesn't, because everything that's working and needs to be looked at is way up there.
Yeah. Yeah, it doesn't get as much attention as it should. The drive system in general, if your drive goes down, you're down, right? Plant's down. And so that part of that drive system is bearings, of course, and we want to keep head shaft bearings greased well and that. But it can be as little as, the high-speed coupling between the motor and the gearbox. It's connected by a little flexible element, cheap, uh, doesn't take up much room. I don't know why anybody wouldn't have more than one sitting around as a spare.
Yes, it is one of the things that one of our co-workers has, with his sage advice, has always said it's the most important thing on a plant when people ask him after setting up silo systems, what spare parts should I need? And his sage advice was, it seems to me that small coupling can shut down your entire plant. It'd be foolish not to have a spare. It's also very, very important if things are being moved that these get realigned properly. They can cause serious failure. At the base, Tony talked about the side wear and loading. There are multiple types of floor liners, both that come originally equipment from the manufacturer, whether it's hard plates that bolt through, whether it is in older days, some AR plates, Hybrinell AR. Typically, that is not used any longer because of the wear components that are available that far exceed that. And the great part of the cost is actually removing the old and or putting in new.
Yes, sir.
And taking that. So we want to do that once and do it well. Chromium carbide is a preferred product where that is a hard surface overlay. It can be extremely helpful. It is very good at sliding abrasion, which is the application for drag slat. Typically, we'll utilize like a multiple overlay. We don't often think about the overlay on plates like that. And when I talk about an overlay, a chromium carbide, it's similar to what we may be used to if you're not familiar with on the side of dozer buckets, your loader buckets, the high chromium and carbide content that we weld on there for abrasion resistance.
It's weld overlay, yeah.
And in that, what is particularly important to kind of understand, this is not meant as a structural component. It's strictly there for abrasion resistance. So what we like to do is that is more of a practical practice is overlay these with as cold a weldment as possible, yet be adhesive, because that minimizes dilution from the parent metal. When that occurs, then we'll do an additional overlay, further preventing dilution. That translates to superior wear. And one of the tricks out there, or things that we should be very cognizant of if we have chrome carbide, is what are we looking for in that conveyor to make sure it still has life? We're looking down at this shiny metal. What do these fracture points in there mean to us, Tony?
Well, the crack, the when you put that weld overlay on top of a piece of mild steel, it's so hard, so brittle that it cracks. And so those cracks are an indication that you have a hard surface on top of that metal. If the cracks go away, then the chrome's gone and you're on top of mild steel and just not got much life left.
So the warning is, as you observe and manage wear, when we start to stop seeing cracks, a bit ironic, but when we stop seeing the cracks, that's the warning sign that we have a wear problem and we'll need to be addressing. Furthermore, into some liners of the past that as far as drag slat floors are virtually no longer used, and that is ceramic floors. While they worked extremely well for a period of time, once we got into PG grades, polymers and the adhesion issues, it became a not as friendly or desirable application. Still, where impact abrasion might occur, transition points, ceramic can still be a good application, but traditionally not in floor plate on drags any longer.
Still have people call for them, and we still stock a wide variety and thousands of pieces at a time, for those impact places where you're putting in wrap or what have you and shoot. So we keep a lot of that in inventory. You spoke about the Nahard castings. We've got tons and tons of those castings in here for, say, your Aztec conveyors and Standard Havens and some others. So we try to keep all that stuff on hand because we do so many dragger builds.
It is, and with that, all these different brands are different sizes. Slats, the way they can be welded into the chain. Tony, if you would, a little bit of why we emphasize if you're going to reuse slats or putting new segments on existing bodies, why we emphasize so much on cleanup, what can happen.
Um, we just start with, when we're replacing those things, we want everything to be good and clean so we can see what we're doing, make sure things are aligned properly. Sprockets, if you have double chain, they need to be timed and match sets, so there's no chance they could be clocked. The teeth can be clocked wrong. Just things of that nature to check. Just good maintenance habits.
We always want to really clean if we're going to reuse any products or putting new segments back on. Really do a thorough job in that application.
Yeah, it's something to look out for sure when you're replacing sprockets and things of that nature, doing partial rebuilds. We do so many complete rebuilds because once you get in there, it's so much labor, so much money to work on this thing that you might as well replace the majority of it. And so what do those look like a lot of times is that the slat will be taken down off the silo. It'll be placed on the ground and everything taken out of it. We replace the floors and replace the side liners, replace all the idler shafts, bearings, new chain and slats, and when you do that, of course, everything needs to be adjusted properly to get it back in good working condition and ready to run again. And one of those items that we see people fail on is their return idlers. So the return idlers are in there, of course, to hold the top strand of the chain up. And how many times do we get somebody calling in that has used those return idlers as hold downs for the bottom strand?
Too often.
Yeah. Yeah, so when that happens, the slats will, as they pass underneath those return idlers, will actually dig into the floor, and it damages slats, it damages the floor. It's just a way to really mess up a big investment that you made in rebuilding the thing.
Absolutely. Also on idlers, normally it can be more economical to cut the smaller idler shafts out, replace the required bearings up through a conveyor when you have it down like this. But uh, I will go as far as to say, much to my surprise, when we came out with split idlers, it added to the expense of an idler, but it also gave the ability to leave a shaft in and scarf off an old idler and put on a two-part idler in halves. Even with the modest expense increase, I still thought that most folks would go with that, and I'm glad to say I was very wrong.
Oh my gosh, yeah.
It's the majority of people wish to have, and there is no conscious means not to have any, if you're going to have spare idlers, not to have split idlers.
Yeah.
In the system, and you see the same, Tony.
I see the same. That's primarily what is purchased these days.
Yeah.
Now, last year, I had two different calls from customers that had done this work. They'd taken the slat down, they rebuilt the slat, everything's brand new, everything's adjusted properly, installed the slat back up on the silo, and not one but two calls about how, we've got this slat, it's brand new. Everything about it's brand new. It's rebuilt. But the chain is riding off to one side. And we scratched our heads over that. Him hauled around for a couple of days on it and finally figured out when they put the slat back up where it was anchored to the silo, it was not level. So it's something else to be very, very cautious of when putting these conveyors back up.
Absolutely. So getting up top side, incline conveyors up on top, because of these horizontal conveyors and lesser incline conveyors, they really have fairly high capacity. It's a common question of why do I have to have this great big drag slat conveyor with 6-inch pitch chain and I have smaller 4-inch pitch chain up on top? Primarily because it's so much easier to just drag horizontally, not unlike screw conveyors. And we can accommodate that. And also, we're trying to create a lower envelope or a lower box height uh, so that when we dump into these conveyors, they can be diverted through a series of flop gates over to whatever silo we need to go or whatever silo run, multiple runs, perhaps traversing over to a whole other set of silos.
Yeah, it's not as much pressure on the chain up there because we're going horizontally, but we are moving the same amount of material. We are moving basically at the same slat speed, so to speak, and we've got much fewer links of chain. So every one of those links of chain is getting articulated around the sprocket, probably 18, 20 times for every time one of the uh, links articulates around the drag slat. So that's a lot of bending in between that pin and bushing. So that needs to be, watched, because that's, again, like we said, where our wear comes from, where the pin and bushing get turned and the gap that's accumulates in there.
Going on to the silos, Tony, ranges from the portable systems we had. You talked about ceramic earlier. That's something I know you do a great deal of in these days, is ceramic cone liners and tub wall
A
liners.
lot of ceramic cone liners and tub wall liners. And the customers that call in for those, we don't hear from needing anything for their silo for many, many, many years. They last us a long, long time.
Yeah, and they are more costly, but they are more prevalent in high production applications. Common question is how far up the tub wall or round cylinder side should we go? It is a subjective question and answer of how high we should go. How much are you running? How's the plant operated? The annual production rate going through any given silo like this. And the right answer is to monitor what the thickness of the walls are. If they are still steel, in today's world, an ultrasonic thickness indicator is commonplace. It's easy to find so that we can measure, map, and record where we are if we have thin spots and what we should do. Um, Cone liners can come in pieces like pie shapes, where the largest width of the pie shape is the opening of the silo at the base where they can be put through. Gates can be safely decommissioned and chained up and disconnected. Um, Pneumatic systems turned off so that we can operate within a silo. It's a very dangerous place to be if we don't do the proper safety protocols. Critical.
We do a lot of the AR plate in those pie-shaped pieces. And then there are also some some really hard AR plate, AR 500, 600 that can come in small little pie-shaped pieces to line the silo cones.
One of
But
the advantages to those is the fact that you can spot repair quite
yeah,
easily.
yeah.
Now, the fact that we're having to spot repair tells us we're probably not utilizing best practices by having impact points in the silo. But that is one of the benefits of that type of application. It's very, very nice apple.
You touched on it earlier too. If you're not operating your batchers correctly, say that something's wrong with your batcher, and rather than fixing it, you just bypass it and hold them wide open. What happens with the wear inside of a silo then?
Certainly it'll wear on the sidewall, potentially, again, dependent upon the material trajectory. Uh, Segregation, which we don't want to happen. But if we're emptying our silo cones as well, that's certainly far from the best practices. We want to keep at least a cone full of a main silo, should be the standard protocol for loadout procedures.
Yeah, we don't want to impact the silo. Cones.
which is commonly done. And the only time that should happen really is when we're filling and we finally perhaps are emptying out our silos. And even then, we don't have to do that so much. That goes back to the level in a silo. How do we know what's in a silo? We, with some degree of humor and frustration, I would like to say, is in my time in the industry, as far back as pulling on Johnson levers on a batch plant, that seems to be as crude as it gets in today's world with all of our automation. Uh, then at that point, we would ask what would be in the silo, and we'd look at our math and see what it said. And for some unknown reason, it wouldn't be precisely what we thought it was. We might have in excess of what we thought we had, or a little bit less. And here we are today, some nearly 50 years forward. Um, Amazing technologies in our control systems that are monitoring everything throughout the plant. And we ask how much are in the silo, and that's categorized. And again, therefore, we must have that load in the silo, and a wheelbarrow load falls out. How are we off? Well, today, one of the things that can be done is through asphalt storage, liquid asphalt, um, hot mix in the silos. We now have measurement capabilities to get within centimeters. I mean, it's extremely precise,
Millimeters.
and it can
Yeah.
true, and it can actually handle this hot, sticky, messy environment, the smoky, steamy environment, um, and they're very precise. So we can look into a silo now, and even batchers, so that we get proper levels and know exactly where we are in the system, with the obvious statement that it, depending on whether we are filling the silo, emptying the silo, the ebb and flow of that cone, whether it's filling and or being drawn from in the rat hole inside, that we get the level in there. This is very, very productive. Speaking in practical terms, um with some uh, companies we work with who were working with us when we put in these first devices, a very, what I would say, highly qualified and experienced operator, and operated a fairly high production facility, put these silo measuring devices in the system, and something we did not anticipate. They certainly got the accuracy, but as a matter of fact, the way they had operated these silo systems, they had were not filling them to its full capacity any longer. When the warning device went off, they were strictly and quickly sending mix elsewhere because they had experienced material backing up in the system, and they didn't want to do that again. Again, not a fun party, as Tony mentioned. Um, but in this case, once we got this confidence level, they quickly went on and started filling the silos higher because they knew of the accuracy, the competence, the dependency of that. And they have over an additional entire triaxle load of material in each silo, something we had not considered. So, in effect, by knowing where the material was in there, they gleaned additional storage capacity in each and every silo, an unanticipated and beneficial consequence we hadn't considered.
Yeah.
Um, Back to silo systems and safety. These are confined spaces. We encourage everyone. There are time delays on many devices on a silo system, air pressure. We must know and understand how these operations work before we send our personnel up there. Or if you are operating on this, understand there can be timing devices. And most importantly, down at the bottom, a common and very sad, common only in that in multiple cases. I'm not saying it's something that happens all the time, but if this system, your silo system, has a safety gate application, oftentimes we have a reservoir tank at the base of many different brands, and that is there purposefully if there's air pressure loss, so that a safety gate can close and not continue to empty on top of a truck. Very sadly, these systems, when they happen to acknowledge a low pressure incident, they will close. So there has been instances within our industry we've heard of, and it's tragic, where people will go into a silo, turn off the air, confirm they've turned off the air. But in fact, these reservoir tanks on the system are holding enough pressure to close silo gates. And when the overall system pressure goes to a low level, it allows them to close the safety gates. And there have been multiple fatalities due to this. So it's very, very important that we chain all gates back, turn the air systems off, and very importantly, that our personnel understand how the system operates so we don't have these occurrences.
Yeah, it's lockout tag out, and the rule of lockout tag out is to remove all energy sources. Well, okay, we turn the air compressor off, that's some of the energy. We turn the electricity off, that's some of the energy, but a lot of people don't know about that stored energy in the safety gate reservoir.
Exactly. So going forward, some of the things and technologies out there that are going on in more and more locations, we're being required to monitor and often cases mitigate uh, blue smoke off of our conveyor systems, silo systems, and even loadout regions. So we're seeing more tunnels and applications on silo systems to where the operator no longer has visual images or a direct line of sight of this. Um, and that creates its own issues, whether we're venting or not with multiple silo systems. We may have an operator that's become very busy who is also doing the silo loadout, or separate personnel who are doing the silo loadout. But all too often we have uh, silo dumps, what's called hood shots, a number of different things where a truck pulls under, multiple silos being loaded out, a lot of activity, and quickly a misload occurs where it might be dumped off the back of the truck, or more importantly, on the hood of a truck or a windshield. Have had fatalities, unfortunately, from this. I've had a massive number of injuries. Um, we have been fortunate through our employees and technology to come up with an AI system called the Look, Lock, and Load. We are going to promote that right here. We're attempting to try to stay away from on our systems here, really pressing a lot of sales promotion. This is something that we're absolutely going to bring up because it is a safety device well beyond anything available in the marketplace. And it can save lives, save injuries, save money. The Look, Lock, and Load is an AI based system, which we have thousands of imagery that we have set up that actually detects, monitors, and watches and puts a safety mechanism in the system so that we don't drop these, causing injury, downtime, costly damages to our own equipment, and it can recognize virtually any type of, there's a allow, not allow system. We've had magnificent success with this, and we bring it up because people just don't know it exists right
Yeah,
now.
so it's a camera system with an electronic boundary, and it sees the bed of the truck, and it knows the exact location of the silo, and if the truck is outside of the electronic boundary that's set in the image, it locks out the pneumatics on the gate itself. So
One of the things we call it is one of the technology developers is the man in the middle. It really is a device between whatever brand of silo loadout exists and the actual solenoid mechanism to allow a silo to be opened. And it's the interrupt between those 2 points.
yeah, so if the person that's operating the loadout um, puts the truck under the wrong silo, for example, they press that button, nothing happens.
Correct. And we have had, and we appreciate it, uh, multitudes of companies and personnel attempting to trick and crash the systems. And we welcome it because we never want it to fail. And it has stood the test of time and effort. It is uh, one of the most prideful products we've ever come out with because it is truly hoping to save people and save money, but save people and injuries.
It's most
We are
important.
currently tracking this, and we were well aware, obviously, this occurred, Everyone has experienced it over time, who's been in the industry for very long. And we had no idea of the magnitude until this product came out and people started advising us how frequently it occurs. Um, so
And the costs of each occurrence.
each individual occurrence,
Yeah.
despite injury. So at any rate, it is a new technology out there. We will promote ourselves on that because it is a one-off product. It is the only thing out there that works like that. So do look at it. We have a lot of glad to set up systems. Most all of the companies who have bought one are buying multiples or for their entire plants. So that tells us we're doing something right. Going on, kind of wrapping up here on our drag slats, silos, blue smoke mitigation, all those things can be done in the systems now. If you will, please bring up and again, uh, put in some requests of what you would like to see here, more discussion on any given topic in this area. And we're going to try to be developing more of this and bringing you, the customers, back into this process as well with some interaction. So as we wrap up, I thank Tony Fritsch again. I'm Steve Elam. We appreciate your time and appreciate your feedback and hope to see you again soon. Thank you.